Hello, everyone. This is the Masonry Swarm. The team is Loose Screws, and I'm Aaron McPherson.
Richardson.
I'm Chris Loy.
The introduction. The problem statement is these workers are doing a lot of time-consuming little odd jobs that brings them away from their main work. So we designed a way to prevent that. Some design requirements were basically the robots just need to do the task they were given, in other words, and then those individual robots are the empty dumpster robot, full dumpster robot, mixer robot, and block robot.
All right, so the dumpster delivery, we have the black spheres for the servo motors, the four wheels. Yellow shell is representing the body, the white block and half sphere representing the distance sensor, the red beams representing the arm that carries the bin. Changes reduce the number of servos for the arm and eliminated the DC motor for rotating the arm. Underneath here, we have the green block for the battery pack, the blue block for the Arduino board, the red and black half sphere for the photoresistor, the four DC motors, and the black box for the two H-bridge motor drive chips, and swapped the IR sensor for the photoresistor. Okay, so we have the circuit design here. We have the actuators or the four DC motors for running the wheels and the two servo motors for controlling the arm. The photoresistor for sensing the LED strip and the ultrasonic distance for sensing objects. Changes reduce the number of DC motors, servo motors, and swap the IR sensor for the photoresistor. Okay, flowchart. Start there. We'll receive a command to either pick up or deliver a dumpster. It will then sense for the LED strip. If it doesn't, it will move until it senses that LED, continue with its sequence. It will then check for an object. If an object is detected, it will reverse until it is not, and then it will continue its sequence. And the Arduino code, we have first section there is for the distance sensor. Next two sections are for the input A of delivering the dumpster, input B for picking up the empty dumpster. This will print during these sequences for its starting, dropped off, returning, waiting, retrieving, new bin loaded, and when it's waiting. And this also has the light sensor change. Okay, part two, checks for the LED strip. It will print lost the LED, checking, check the distance, and prints when the object is detected. Here we have the simulation start. If it receives input A for picking up the motor, it will drive over to area, we'll drop the bin off, reverses, heads back to the starting area. I'll wait for a new command. It needs to pick up a new bin. We'll drive over to the bin, load it, and then waits for its next command. Light sensor loses the LED strip, prints on the monitor, checks, moves around. Distance sensor, if an object gets too close, will stop, reverse, and print object detected.
All right. The third robot is the mixer robot. The red there is the shell. The blue is the oscillating pouring chute. There's supposed to be a door there, but that'll be done manually. Connected to the pouring chute is a shaft that's connected to an actuator controlled by a servo motor. The white box is the rechargeable battery. The gray box is where the circuit and Arduino is. The bottom picture shows dimensions. The orange is the mixing shaft within the chamber, and then the black box is the DC motor that controls that shaft. The lighter blue there on the front is the ultrasonic distance sensor, and the purple below it is the photoresistor for the LED strip. Under the robot, the wheels are turned by DC motors, and the big lid on there is to prevent spillage when mixing. This is my circuit design. I use DC motors, rotary actuators, and servo motors. I also used photoresistor and ultrasonic sensor. There's a few things that changed. One of them was change it from 4-wheel drive to 2-wheel drive, and another one is photoresistors being used. The LED, this part of the circuit design, the LED strip is on the ground, the photoresistor acts to it. The DC motors turn, the ultrasonic sensor senses within a range. The DC motor turns the mixer and starts mixing the paste. The servo motor will start oscillating, and the LED strip is, when the LED strip is turned off, the motors will stop. And then the flow chart says about roughly the same thing. Once it receives signal for the task to start, the DC motors will go. As the robot's getting to its destination, the ultrasonic sensor will start its reading. When that happens, the wheels will stop and that's only if there's an object within 3 feet of the ultrasonic distance sensor. And then it'll send a signal for the next robot to go. And the other thing that's changed is I decided to run the servo motor all the time instead of only when it reaches the destination. These are some code snippets. And I'll share this. Looks like I already have the simulation going. So the servo motor's going right now. It's oscillating that chute. And then when the LEDs are turned on, both of these motors will go. One's for the wheel, one's for the mixer. When the ultrasonic distance sensor gets within that 3-foot range, this wheel one here will stop, just like that. And it should continue again now that it's out of that 3-foot range. Just like that. And then when the track runs out or the LEDs are turned off, both motors will quit. That servo motor is still going. Yep, just like that. All right.
All right, robot 4, block moving robot. This robot's used for moving pallets of blocks. It's about 3.5 by 6 foot long. There's a compartment for the battery. It has a cover. The gray box is the Arduino board and wiring inside. It's got 4 wheels. Rear wheels are driven by a DC motor and 2 front forks for lifting. The bar run from the top of the forks to the back can be shortened with a screw attached to a DC motor. The screw has a distance sensor. Will pick up the distance of the flag attached to the screw and dictate how far the forks are lifted. There are 2 distance sensors in blue. One is located on the bottom of obstacle detection. The other is detecting the distance the forks have to move. There's a servo motor connected to the front wheels for steering. The DC motor in orange to provide forward motion. 2 photoresistors are used to sense an LED strip on the ground that the robot will follow. Design changes include using the photoresistors instead of IR sensors, and I added a distance sensor to detect fork movement because there was no limit switches in the Tinkercad or Arduino simulation. Here's a picture of my circuit. You can see the motors. You can also see the servo motor and the distance sensors along with the 2 photoresistors. Here's the flow chart. Once the robot's told to start, it'll check to see if there's any obstacles within 2 feet. If yes, it'll stop until the obstacle is cleared. If not, it'll ask if the forks are raised. If no, it will raise the forks. It'll ask again, forks raised. If they are, yes, robot follows the LED strip on the ground. Has the LED strip ended? No, it'll keep following it. If it does end, then the robot stops, drops the load, and returns to the starting point. It's just a picture of some of the code, which I'll show you what this code does in just a moment. We'll go ahead and start the code here. Going to ask me to type the number of the robot I want to activate. Robot 4, hit enter, and let's see what happens. All right, nothing, because it's not the distance sensor is telling we got something in the way. Now that we don't, this motor's turning, it's lifting the forks. Once the forks get within 2 inches of the flag, that motor stops. Forward motion starts. It's following the LED strip on the ground. These light sensors here. Right sensor senses more light. It turns to the right. The left one senses more light. It turns to the left. We'll keep following it till it gets to the end. All right, this is the central hub flow chart. The first one is for robots 1 and 2. Central hub is going to tell the robot 1 to deliver an empty bin to a location. Once it's delivered it, it's going to let the hub know, and it's going to return back to its home starting point. When the hub receives that information, then that the bin is full, it's going to send robot 2 out to pick up that bin and put it in the dumpster. Once it's done with that task, it's going to let the hub know, and it's going to return back to the home position. And this cycle will continue till the job is finished. In the next flow chart, we have robots 3 and 4. Hub is going to tell robot 3 to mix and deliver mortar to a location. Once robot 3 has mixed and delivered the mortar location, it's going to let the hub know. Then the hub's going to tell robot 4 to deliver concrete blocks to the location. Once robot 4 has delivered those blocks, it's going to let the hub know, and it's going to return back to its starting location. And this will also continue until the job is finished.
All right, for the entrepreneurial aspects. So this is mainly deciding about the price, and it's taking the job of a lot of these giant forklifts and even some warehouse forklifts, and it's taking care of this mixer that a lot of masonry workers have, obviously. And with all that adding into the cost and everything, a good price for the swarm would be around 60 grand after you take in the labor replaced and the workers replaced and, things like that, that you can't really put a price on, but you kind of have an idea. And this is a new concept, but there are machines out there that look and do similar tasks. Here is a picture of something that I based my design off of, the mixer robot. I based it off of this. It looks kind of similar. But this design offers a big value to these workers, and I think they'll get a lot out of this.
In the summary, so the lessons that we learned from this is how best to choose our robot designs, cooperate in a team during many different circumstances, since this took place during the Thanksgiving holiday, coordinating with differing schedules since we are all working. Some of the changes we make if we could do this again is to learn more coding to make that easier and to choose simpler robot designs. Our robot swarm accomplishes the goal of automating tasks for construction workers.
And those are the references, and that's our presentation. Thank you.
Thank you.
Thank you.